Hey guys, so today is day 2 for absolute value equations. Now today we're not just going to be dealing with the equations, we're going to be dealing with absolute value word problems. So let's go ahead and write down today's objective. Today's objective is I can solve and graph absolute value word problems. Now before we actually start getting to the word problems, let's just get some more experience with what we did yesterday. Alright, now for number 1, we have 11 times the absolute value of x minus 9 equals 44. Remember, I told you guys to always cover up the equals and see if the absolute value is by itself, and it's not because you can see that there's an 11 outside of the absolute value. So we got to get rid of that 11. So what we're going to do is divide both sides by 11, and that's going to allow me to cancel it out on the left side, and on the right side, 44 divided by 11 equals 4. So now we have the absolute value of x minus 9 is equal to 4. Now if I cover up this equals 4, you can now see that the absolute value is isolated because there's nothing outside of it. So now we can go ahead and split it into the two equations. Now what you're going to have is whatever's inside the absolute value set to two different values, the positive and negative value of this number. So what we're going to have is x minus 9 equals negative 4, or x minus 9 equals positive 4. Now we're going to solve each of these, and it's always going to be the same thing, same steps that you're going to take when you split them up. So for the first one, we add 9 to both sides. That's going to get me x equals 5. For the second one, we also add 9 to both sides. That's going to get me x equals 13. Now to finish this off, I'm just going to put the or in between them. So this is my answer, x equals 5 or x equals 13. Now again, since these are since this is an equal sign, there's no inequality here. This is just going to wind up being 2 dots on the number line at 5 and at 13. Okay? Now I want you guys to do number 2 on your own. Number 2 is 7 times the absolute value of 5x plus 8 equals 14. Go ahead and solve this one on your own, and then we'll go over it. Alright, so like the other one, if you cover this up, you can see that the absolute value is not by itself. So how do we get rid of that 7? Well, we're going to divide both sides by 7. That's going to cancel out on the left side. The right side, I'm going to get 2. So now I have the absolute value of the absolute value of 5x plus 8 equals 2. If I cover that up, you can see the absolute value is by itself now. So let's go ahead and split them up. We're going to have what's inside the absolute value equals negative 2, or what's inside the absolute value equals a positive 2. And again, remember, it's going to be the same steps in both of them. So on this first one, we're going to subtract 8 from both sides. That's going to get me 5x equals negative 10. Divide both sides by 5, and then we get x equals negative 2. Now on the other side, we're going to do the same steps. So we're going to subtract 8 from both sides. 5x equals negative 6. And then we are going to divide both sides by 5. Now when you do that, over here you can notice that it's going to cancel out on the left side over here, but on the right side nothing cancels and you can't really simplify it. This is equal to negative 1.2, but you can just leave it as the fraction negative 6 over 5. Okay, so I'm going to graph these two. The smaller one is the negative 2, so that goes first. So negative 2, and then over here we have negative 6 over 5. Alright, so that is number 2. Let's go to number 3 now. Now for number 3, this is the actual word problem. It says, you are a quality control inspector at a bowling pin company. A regulated pin must weigh no more than 5 ounces, more or less than 57 ounces. Solve the absolute value equation, which is absolute value of W minus 57 equals 5, to determine the maximum and minimum weight of the bowling pin. Now, basically they just want you to solve this absolute value equation. And then once you solve it, you're able to find the maximum and minimum weight that is allowed for a bowling pin. Okay, now to solve it, right, the absolute value is already isolated, so we're going to go ahead and split it into the two equations. So we have W minus 57 equals negative 5, or W minus 57 equals 5. Now, on both of them, what you're going to have to do is add 57 to both sides. That's going to get me W equals 52, or W equals 62. Okay? Now, this is the answer. Now, what they want you to specifically say is what is the maximum and minimum. The maximum would be just the higher of the two. So that's 62 over here, okay? So the maximum you would say is 62 ounces. What is the minimum? Well, that's the smaller of the two, which is the 52 over here. So the minimum weight would be 52 ounces. Now again, these would be the maximum and minimum weights that are allowed. All right, guys, for number 4, I'm going to read this for you, and then I'm going to let you guys try it on your own. It says, the street built in the city must be 25 feet in width with a tolerance of 2 feet. Streets that are not within the tolerance width must be repaired. Solve the absolute value of W minus 25 equals 2 to determine the maximum and minimum width of the street. Go ahead and do this on your own, and again, you have to describe the maximum and minimum of this problem. Go ahead and do that right now. All right, so let's go ahead and solve this really quick. So this is the equation that they gave us. So what we need to do is, now you can see that the absolute values are already isolated because there's nothing outside of it. So we're going to go ahead and split it up. So we have W minus 25 equals negative 2, or W minus 25 equals positive 2. Now when you add 25 to both sides, this one you get X equals 23, or W equals 23. This one you get W equals 27. Now what does that actually mean? Well, what that means is we have a maximum of 27 feet. So that's how wide, that's the most it could be. All right, and then a minimum of 23 feet means that's the skinniest it could be. Okay? All right, hopefully you guys got that right. Now we're going to go to this new part, which is number 5. Let's go ahead to the back side of the paper. All right, guys, here we go on the back side. So it says, given the graph, tell whether it is a compound and, compound or if it's an absolute value problem. Then what you're going to do is write the compound inequality, or you're going to write the solutions of the absolute value. Now you should be able to just look at the graph and already know if it's an and, an or an absolute value. Now looking at number 5, I can tell that this is going to be an absolute value because the fact that there is no shading at all. The only thing we have is 2 closed circles at 4 and 6, so we know that it's an absolute value problem. Therefore, the answer over here would be the solutions part, and the solutions would just be x equals 4 or x equals 6. And again, we do have equal signs because it's absolute value. If it was an inequality, then there would be inequality symbols here. All right. Now, number 6 does have shading. Specifically, you can see that the shading goes outward. Okay. Since the shading goes outward, you only have that if it's a compound inequality, and specifically an or compound inequality. Now, over here, when you want to write down the compound inequality, you need to compare x to these two numbers. Okay, so we're going to compare x to -1. We're going to put the or because it is an or problem, and then we're going to compare x to 5. Now what you want to do is you want to figure out what shading, what number it is in the shading to help you do that. Now, a number that would be in this shaded region would be like -100. Over here, -100 is less than -1. Again, we do have an or equal to bar because it is a closed circle. Now over here, we're going to see that we can put in this shaded region +100, and +100 is greater than 5, and it's or equal to bar because it's a closed circle. Okay? Now, number 7 is also shading. Now specifically, this shading is in the middle. So we have shading in the middle. Therefore, this is a compound inequality problem, but since the shading is in the middle, it is an and compound inequality. All right, now over here, there's 2 ways to write the answer. I'm going to write both of them. All right, the first way is by merging it, and because it's an and problem, it's easy to see that you can merge it because the 9 and the 16 are going to be written with x in the middle. You see how the shading's in the middle? X is in the middle, okay? Now, because it's an and problem, we know that they're both going to be less than or equal to, because the number in this shaded region would be like 10. 9 is less than 10, and 10 is less than 16, okay? Now, say that you wanted to write this with the and showing, If I cover this up, you can see that we have 9 is less than or equal to x. That's the first part. And if I cover this up, you can see that x is less than or equal to 16. So that's how it would look if it was split. Okay? All right, we'll do number 8 together as well. Now this is another OR because the shading is going out. And then we're going to go ahead and put over here, we're going to write our comparisons. We're going to be comparing x to -10, and we're going to be comparing x to -6. Now over here, -100 would work, so it is less than, but it's only less than because this is an open circle, so there is no or equal to bar. This one is going to be greater than, but there is an or equal to bar because it is a closed circle. Okay? Now I'm going to let you do the rest of this on your own. If you have any questions, make sure you have it for me tomorrow. All right? I'll see you guys.